Hi, welcome to this video on lesson 4.1 in math in Envision. And we're going to do part 2 here where we're actually looking at writing expressions. So example 1 and example 3, you have to write expressions. We already looked at example 2 first where you were evaluating. So let's write expressions today. In writing expressions, what we're going to do is use a variable to represent a value that can change. So a variable is something that can change and fluctuate. We're going to have numbers that are constant that don't change, and then symbols that use to kind of tie it all together. So an automatic dog feeder dispenses 2/5 of a cup of dog food each day. That's going to stay the same. Each day, it's going to let out 2/5 cups of dog food. So that's going to stay the same every day. That's called a constant or a constant rate because it's a rate, a unit rate, right? 2/5 cups per day. So it's a unit rate. Now, they want to know what expression can be used to determine how much it is each day. So it starts out with 20 cups of food. And as the days go, if it's full of 20 cups of food, every day it's letting out food. So it's losing food each day. How much food each day? Think about it this way. If I change this and said the dog feeder dispenses 2 cups, say it dispenses 2 cups of food each day, then if it starts at 20, then after the first day it would have 18 left. And after the next day it would have 16 left. And after the next day it would have 14. Because it'd be losing 2 cups each day. But it doesn't give that much food to this dog. The dog doesn't get 2 cups of food a day. It's a little dog. It's only getting 2/5 of a cup each day. So if at first it has 20 cups, the next day it's going to have 2/5 less than that. So the food is coming out, so that's subtraction. So in this expression, what expression can be used? An expression means that we're going to be using this variable d, and we're trying to find the amount of food. So in order to find the food, I would have to take food away from food to end up with food. Maybe that confuses you. I know I'm starting with 20 cups of food each at the beginning. The food is coming out. So I'm subtracting it. How much am I subtracting? I'm subtracting 2/5 of a cup. Well, if that's all I did, then that would mean that 20 minus 2/5, then the end result would be 19 3/5. But that would only be after the first day. So since it's losing 2 cups per day, in order to figure out how much it's losing each day, I have to multiply the days times 2/5. So now I have my expression. It's losing 2/5 cups of food each day. So I multiply the 2/5 of cups per day times the days, and I'm taking that away from the food. And there's my expression. I'm done. It's that simple. Boom, boom, boom. So this one's a little more complicated. Actually, we're going to do 2 things. It says we're going to first write an expression, and then we're going to evaluate the expression, because the goal is how much money did they have left after paying for lunch. So Malik and his 2 friends earn $M in 1 week doing odd jobs. They split the earnings so that each friend gets 1/3 of the earnings. So let's pretend they make $300. Then each of them gets 1/3. Each of them would get $100. Let's say they made $24. And they're going to split it up so each of them gets 1/3. So 24, 1/3 of that would be 8, 8, and 8. So whatever money they make, each of them gets 1/3. Okay? Malik uses $32 of his earnings each week on lunch. So he gets 1/3 of it, and then from that third, he's spending some of that money on lunch. Last week, he and his friends earned a collective amount of $963. How much money will he have left after paying for his lunch? What we're going to do first is we're going to write an expression that Malik could use anytime. Because if he's always using the same amount of money each week for lunch, then that's going to stay the same. So they're always going to earn M dollars. We're going to use M to represent the amount of dollars each week, and that could be a different amount. So maybe one week they earn $963, another week they earn $1,200, and another week they only earn $300. So that could change from week to week. That's why we're using a variable. What doesn't change is that they're always going to each get a third of it. And the other thing that doesn't change is that Malik is always going to spend the same amount on his lunch. So the things that aren't going to change, those are numbers. But the things that could change are variables. So let's use those variables and those numbers in order to create an expression. So first he's going to earn the money, and then he's going to spend money. Well, we're going to pretend like that's what's happening. So let's say they earn M dollars one week. Well, does Malik get to keep all of that money? How much of that does he get? He only gets 1/3 of that. So I would have to multiply that money by 1/3. Some of you are like, no. You divide it by 1/3. No. You take the money and divide it into 3 parts. That would be M divided by 3. Or I can do 1/3 of it. 1/3 times M. These two things are mathematically equivalent. So either I can write this as M divided by 3, like the money divided into 3 parts, or 1/3 times the money. I have 2 choices. I can write it either way. You can choose, but just so you know, it's not divided by 1/3, because then he's going to get a lot of money. So don't do that. So I'm going to write he gets 1/3 of the money. So 1/3 times the money, because of means times. And then he's going to spend money from that. So he's going to use that money to buy his lunch. How much of that money will he use? Well, from this money, he's going to take out $32.50 to pay for his lunch. So there's the expression. Now I can use that expression. Here's my expression, which I wrote. And now I can use that expression to figure out how much money he has left after paying for his lunch by substituting in the money he earned into my expression that I wrote, and then evaluating it like we learned yesterday or the other day, whenever that was, how to evaluate expressions. So now I'm going to evaluate this by multiplying first. So 1/3 times 963 will be 321. And then I'm going to take away $32.50. And that will be, let's see, so 321 minus 32.5 is $288.50. And that should be the answer in your book, $288.50. So there you go. We wrote an expression and we evaluated it. So now you can do the try it on that page, whatever it is, probably 191 or maybe 189, somewhere around there. Amelia earns $8.74 per hour, plus means add, a gas allowance of $3.50 per day at her job. How much does Emily's job pay in a day when she works 5.5 hours? So she's working 5.5 hours, and but she gets it only for one day. So she earns $8.74 per hour, plus she gets $3.50 per day. So since we're only worried about days, even though the $3.50 per day is a unit rate, that unit rate is only one day. So we don't need to multiply that by anything. We look for the other unit rate in the problem, $8.74 per hour. When I see a unit rate, that means I'm multiplying by something. Like I said here, the $3.50 per day, It's only one day. So yeah, I'm multiplying by 1. And $3.50 per times 1 is $3.50. So that unit rate's taken care of. But the hours are changing. She might work different hours each day. As a matter of fact, this day she works 5.5 hours. So let's first write the expression. So Emily earns, you can pause now and write the expression and then rejoin us. Okay, so we're back. Emily earns $8.74 per hour. So that's $8.74 per hour means times hours. That's it. It's that easy. Plus, see, plus symbol. That's it. $3.50 per day. Well, it's only one day, so it's $3.50 times 1. So there's $3.50. And that's it. That's how much, this is her expression for how much she earns each day. It's that simple. So now I've written the expression. Now we're going to substitute and solve. So you can pause now and solve the rest of this. And we're back. So I'm going to write $8.74 times the hours. So I'm leaving an open space plus the $3.50 she's making just for the day for gas. So what goes in here? Well, we're using 5.5 hours. So 5.5. So then the last step is to simplify. So we're going to use the order of operations. We would multiply before we add. So I'm going to multiply here before I add in the 350. So when I simplified, I have $48.07 for the amount that she's earning hourly. And then add in that extra gas money she's receiving. She has a total of $51.57. So there we go. So in general, to write an expression, is kind of tricky. Here's a little tip though. Look for a unit rate. If you're given a unit rate, then that usually means you're multiplying by something. So if it says, like in this number 4, if it says 1/4 gallons per minute, then I'm multiplying by minutes. $3.25 per pound. Per pound, I'm multiplying by pounds. $3.50 per day, I'm multiplying by days. So look for the unit rate. That tells you that you are multiplying something. And then look for words like total, that means add, plus, that means add, taking away, that means subtract. And that will kind of clue you into what's happening. Also, be thinking about what's happening in the context of the problem, because try to make sense of it and think it through. If you're really getting stuck, try thinking about it and making up a number. Like sometimes what I do for myself is like here I would try to think about it and say, imagine 10 minutes. Well, what would the answer be if it was 10 minutes? And then kind of go back and see what math I use to get the answer. Because sometimes you're actually better at writing an expression when you know all the numbers than you are when you have a letter. So try that for yourself and see if you can think through it once you give yourself a number. We've tried that before in the past too. All right, well, good luck. I know you can do it. Thanks.